Hello, John here with another video, and this is going to be a video series dedicated to machine language programming. And what I've decided to do is, if you remember and you follow my channel, about a year ago I bought myself an SD to IEC system, and I got a bit fed up of doing the open 15, 8, 15, whatever to make it mount a disk or whatever. So what I did is I wrote a system called TDSOS in 24 hours, and here it is. And what it did was it pretended to be a cartridge, and so the 64 treated it as such. And in this system I had encoded some more basic keywords to do specific things for the disk drives and for the SD to IEC. And I put it out there for you guys to mess around with and stuff like that. And it has issues. It's got some errors in it. You know, if we get an error while doing a catalog, like so it can't read the directory, the system has a bit of a fit, and it takes a while for it to get back. Sometimes you can't, and you have to do a reset. And so what I've decided to do is to recode this entire system, but I'll do it in a video series where you guys can comment and look at the code and stuff like that, and we'll do one or two commands depending on how complex they are in each video. And then once we've got all the commands all sorted out, then we'll work on the basic tokenizer, and then we'll work on the making it the 64 think that the program we've just written is a cartridge. And so this is going to be the first in a series of videos all about this sort of stuff. So like catalog, right? And you see it paused there. It's because I've got a key tester, and because it's too quick it took my enter as a key and paused it. But I want to make that better, you know. Status and just basically put error trapping in it so we can detect if there's a problem with the device and all that, and just make it a little bit better, you know. It was quick, cheerful, and it was a proof of concept. As you can see, it says January 2017, so it was a year ago. So what I'm going to do is, let's go back to my slideshow. What we're going to do is, this time instead of calling it TDSOS, we're going to, what I've decided to call it is CIDOS. And CIDOS means Commodore Integrated Disk Operation System, and that is going to be the name of the program. So what we're going to do in CIDOS is we're going to encode the normal disk operations into the system. And so the word in bracket is going to be the basic keyword, and for that particular operation. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 operations for disk operations. We've also going to encode the SD to IEC. Oh dear. Let's sort that out. IEC. Operations. So we're gonna. So the same thing in brackets is going to be the encoded keyword in BASIC, and we're going to have some ROM operations, and these operations are not disk operations. They're not SD to IEC operations, but just operations that I want to encode in there. So directory, which will load the directory but not actually load it, just puts it on the screen for you, and that will be and using the catalog command. So here we go. So the disk commands, the first one is status. Now status tells the device, either disk drive or SD to IEC, what is your status, and it returns back 4 fields. You know, the field 1 is the actual error number, field 2 is the description of that error, field 3 is the track number, and field 4 is the sector number of that error, just in case it is related to the disk. So here's a couple of examples. So example 1 is 34 syntax error, and that's normally when you've sent it a command and it doesn't understand what you've sent it. 0 OK 00 means I am OK, I am ready to go. And a typical read one is like when you do load $8, sometimes it can't read the directory, and you would get 21 error, read error on track 18 sector 0. So that's going to be our first command. Our second command is going to be is Initialize, and what Initialize does is it reads the block allocation map of the disk. So, and the reason for this is the ID of the disk. The disk has an ID, and when people formatted their disk, they gave it the same ID. And the problem is it's supposed to be a unique ID, because that ID is what the disk drive uses to see if you've put a new disk in. So if you've got the same ID on all your disks, the disk drive doesn't read the BAM, and so when you go to save a file, it could potentially overwrite a file that's in the system. And so Initialize forces that block allocation map read. Now if you add unique IDs, then every time you put the disk in, when you put a disk in a drive, it normally spins up for a bit. That's because it's reading the header, and if the ID is different than the one it's got in its memory, it will actually go off and read the BAM as well. So it is crucially important that you have unique IDs for your disks. But if you don't have unique IDs, we have a way of getting the disk drive to initialize based on the disk that's in the system. Disk operation 3, well, this is validate, and we're going to call it collect, and it's like a defrag sort of in modern money. And what it does, it frees up all allocated blocks that are not assigned to any normally closed file. So if you've got a file and you left it open and didn't bother closing it, that allocates blocks, but it doesn't permanently allocate them. And so what the collect does, it looks at it and and looks at the data and sees if it was a closed file or not. If it doesn't, it marks it as not allocated, and it will do that for the entire disk. And this is one way of freeing up a disk, because you could have a disk with, say, one file on it, it's got 16 blocks, and then at the bottom of the disk, when it tells you number blocks free, you could have 23, and you're going, huh, I have 600 and something, I've only used 16, I should have 600 something. And that's because it's got allocated blocks to files that don't exist, and so validate frees all those blocks up. Disk operation 4 is rename, which is basically rename an old file into a new file. So rename John into Richard. Disk operation number 5 is copy, and copy allows you make a duplicate of a file that you've got on the disk. So what you do, you're going to copy the old file name into a new file name, so you end up with 2 files exactly the same but with 2 different names. Or for sequential files, you can actually merge files together. So you could say copy into this new file old file 1, old file 2 and old file 3, and it would take those 3 files, merge them together in the order that you've put them in the string, and then made it into the new file name. So we're going to do that as well. Operation 6 is scratch a file. Well, in this case it's going to be called delete, and with delete you're going to want to delete unwanted files off your disk, and this is the system that will allow you to do it. Sometimes you can put some wildcards into the scratch system, and it will tell you how many files it has deleted, and that normally comes with the status, and it's the track number gives you the number of files that it's deleted. Operation number 7 is new disk in 1541 terms, or format in R encoding, and this will allow you to format a disk completely blank, the whole lot, with the header and a unique ID. I can't stress this enough. You need a unique ID for every one of your disks. Don't have two disks with the same ID, or you have to initialize each and every time. Disk operation 8. The first one is not actually a disk operation, it's something that we're going to write to be able to change the device number that it's pointing to. So that is just basically to change it from device 8 to device 9. Lock. This is the ability to write protect or delete protect a file on the disk. Now it works okay on a physical hardware disk, but when you come to the virtual hardware like SD to IEC, and I've done it wrong there as well, look. Oh no, I've got it, done it right. And vice, it doesn't support it. So you've got to be careful when you're using the lock and unlock on SD to IEC and emulation, because it doesn't work on these tasks. But in the real world, it does. You cannot delete a file or rename a file if you've locked it. The only way you can do that is to unlock it, and so we'll have the unlock command as well. Now we're coming on to the SD to IEC operations, and so the first one we're going to do is mount disk, and this will allow you to mount a D64, a D71, a D81 file and make that the disk that you want to work on the Commodore 64. The beauty of this is that you can emulate disks on your real hardware, and same with the emulator. But you don't have to mount a disk. You can use the SD card in its entirety, but the problem with that is the directory structure of a 1541 only allows you to have 144 files in a directory. So you have to make sure that you've only got 144 directories in your root directory, and each directory has only 144 entries, so you could have a very deep directory list. And most users don't do this, they just use the D64 file types or D71 or D81 file types as their data store. The next one is dismount, well, which is the opposite of mount. You know, you take the disk image that you currently mount and you just dismount it, and it puts it back into SD card mode. The next one is the ability to change directory to the root directory. So if you've gone down a very complex directory structure, you can actually jump straight to the root, and that's a pretty important feature, because sometimes you can get a little bit lost, especially with the 144 entries restriction. Operation 4 is switch a directory, and this is where you can go up a directory on your SD card. So you can so you can just do switch directory John, and it will change directory to John if it does exist. If it doesn't exist, then we need to be able to record that error, because at the moment I don't think it does. Make directory, well, self-explanatory, to make a directory in the current directory that you're in. Remove a directory, self-explanatory, to remove a directory that you're currently in. And they are all the SD to IECs. Now we've got one extra one, which was the ROM one, which is to do a directory listing. Now, when you load $, into memory, it actually loads a program. Can't run it, of course, because it's just gibberish. But what it does, the program always starts with 2 bytes, and this is the location of where it's normally going to load. So it would be typically 0108, which is the start of basic memory. Then you've got a link address which links you to the next next basic line, then the line number, then the content of the line encoded, and then you have a 0 at the end of the line to mean end of line, and you have this all the way down. So this is how we've got to read the directory in. So we've got to read the first 2 bytes and do nothing with them, then read the next 2 bytes, do nothing with them because we don't need them. Now these 2 bytes are important because the line number in a directory listing is the number of blocks being used for this file name, and then the file name is in this bit, and then we terminate it with a 0. So as soon as we detect the 0, we know we're on a new line, so we have to run through this again and again. And so this is how the category is going to be worked. So we need to write this function to do this specific thing. Alright? So what I am proposing to do is, in this series we are going to code it together. At the end of it we'll have a working disk operation system for the Commodore 64 and the Commodore VIC-20, and we're going to code it using CBM Proj Studio and using some of the techniques as described by Derek Norris in his book, but instead of being based on games, this is going to be based on a business application, so to speak, a utility, where we're writing extended commands for BASIC to allow us to interface with the disk without having to do complex open and closed files and prints. So with that, I hope that you will join me on this journey and comment as much as you want, or even contribute. If you see something that I've done and that could be done better, please, let's all join in and build this system together, because at the end of it all the source code will be out there and the system, and anybody will be able to use it who's got a 64, a disk drive and an SD to IEC. So I hope to see you on the next video where we will start building the project. And with that, I'll see you next time. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.